Hi friends, welcome to Simplify Maths. Today we are going to learn Understanding Quadrilaterals, Chapter 3. It is an introduction video, Part 1, Class 8. We are going to learn different types of curves in this chapter. For this, we need to know what is a plane surface. What is a plane surface? A two-dimensional and a perfectly flat surface which extends in all directions is called plane surface. Okay, what is two-dimensional? Easy, don't get confused. Two-dimensional means 2D. 2D means it is a flat thing measured only in length and breadth, no depth or no thickness. See, for this paper only length is there and breadth is there, right? No height or no depth. Example, paper. So what are the other examples we can give? We can give this table also. Table is also flat. And flat surface of the cube, cuboid, even just imagine an ice cube. The flat surface is there, no? That is also 2D, two-dimensional thing. That is the plane surface. Even we are having mirrors, no? The mirrors are flat surface. See, this is a phone. This flat surface, see, it has only length and breadth. So this is also an example of the flat surface, plane surface. This is an example of the plane surface. So we can give enormous examples for plane surface. What are they? Paper, even almirah, table, flat surface of the any objects like cell phone, even mirror, our TV, everything. These are all called plane surface. So don't get confused. Plane surface means it is a 2D thing, a two-dimensional and a perfectly flat surface which extends in all directions, right? Next, plane curve. A figure traced out on a plane surface. A figure means a drawing traced out on a plane surface with the help of a pencil without lifting it and without retracing any portion of the drawing other than single points. See, just see here. This is a curve, right? This is a curve. Just I am using this pencil to trace like this. I am not lifting, taking and doing. So these are all curves. Even C is a curve. L is a curve. O is a curve. So many things we can. Zigzag is the curve. 8 is also a curve. See, it can intersect and without retracing, we should not retrace any place, any portion of the drawing other than single points. That means it can overlap a single point at a single place. That means it can intersect. But we could not retrace the thing, right? So these are all curves. So many things we can give. See? 5, 6, W, U, V. We cannot do F and other things. See, F means you can do this one line and this one. And for the other line, we need to lift our pencil. So we should not lift. If we lift, it is not a curve. So for doing F, we need to lift our pencil and need to draw a line here. So it is not a curve. So F is not a curve, right? Even N, like this we can give enormous thing. So just try for A. A we can do like this. Without lifting our pencil, we can't do this line, right? So this is not a curve. Curve means a figure traced, a drawing traced out on a plane surface with the help of the pencil without lifting it and without retracing any portion of the drawing other than the single points. That's all. Easy, right? Types of curves. What are they? Open curve, closed curve, simple closed curve. Open curve means curve that does not end at the starting point. That is called open curve. It's very easy. See, C is a open curve. It starts here and ends here. So this is a open curve. Correct? Even S is a open curve. It starts here and ends here. No meeting point between these two things. This N is also an open curve. If we do like this, this is also an open curve. Some zigzag, random zigzag thing. This is also an open curve. Similarly, we can give enormous amount of example for this. See, this is also an open curve. Starts here, ends here. In alphabets also, we can give so many open curves. See here, U is an open curve. W, M, Z, these are all open curves. Even we can give 5. We can give 6. It starts here, ends here. Just to see the starting point and the ending point. If it is different, then it is called an open curve. That's all. Next, closed curve. What is closed curve? Curve begins and ends at the same point is called closed curve. What are the curves? Starts and ends at the same point. In alphabets also, we can give O, right? O. O starts here and ends here. Even H. It starts at the same point and ends at the same point. It is closed. These are all interior of the figure. These are all called closed curves. See, figures like this, and we can do n number of things for closed curves also. Square, rectangle. See, starts at one point, ends at the same point. Diamonds. Like this, we can give so many things. In our rangolis also, we can give closed curve. Like this. Right? Even like this also. So, these are all examples of closed curve. Now, simple closed curve. What is simple closed curve? It is just a closed curve only, but which does not intersect itself. See, in the closed curve, here some intersection happened. These are all not simple closed curve. They can be tell us closed curve, but not simple closed curve. Simple closed curve means a closed curve which does not intersect itself. It should not intersect. This is the simple closed curve. Square is the simple closed curve. Rectangle is the simple closed. That means it should start and ends at the same point without intersecting any portion of the drawing. That is called simple closed curve. Even we can, this is also a simple closed curve. Right? Triangle is also a simple closed curve. Pentagon, hexagon, these are all examples for closed curve. For different types of these curves, can you do more and more curves using numbers, alphabets, and even some imaginary design? And post your answers in the comment section. Here comes the main part of the chapter, polygon. A simple closed curve made up of only line segments. Just we have learned simple closed curve. If this simple closed curve is made up of only line segments, then it is called polygon, right? Only lines. That means it should not be a curved thing. This is also a simple closed curve, but this is not a polygon. Only, see, square is a polygon. Even triangle is a polygon. It should be made up of only line segments, not with this curved lines, right? So, a simple closed curve made up of only line segments. It does not intersect itself. That is the main thing of the simple closed curve. So, a simple closed curve made up of only line segments is called polygon. Now, classification of polygons. Classified as per the number of sides or vertices they have, right? What are the things? See, just listen here. This is a triangle. So, made up of 3 line segments. These are all sides. 1, 2, 3. Sides means this edges or sides. And vertices. This points formed, between 2 edges. These are called vertices. So, it is these polygons are classified as per the number of sides and the vertices they have. We will see these in detail. See, from the NCERT book, number of sides or vertices. See, if it has 3 sides or 3 vertices. sides means these things, 3 sides or 3 vertices, then the figure formed is called a triangle. This is a polygon which is a triangle. Now 4 sides, 1, 2, 3, 4. So 4 sides and 4 vertices. This is called as quadrilateral. Even, square, rectangle, these are all parallelogram. These are all called quadrilateral. Next, 5 sides and 5 vertices called as pentagon. 6 sides, 6 sides or 6 vertices called as hexagon. 7 sides or 7 vertices is called as septagon. Not heptagon, it is called a septagon. Now 8 sides, right? 8 vertices, this is called octagon. 9 sides or 9 vertices is called a nanogon. 10 sides or 10 vertices is called decagon. Similarly, it will go like this. If it has n sides or n vertices, then it is called n-gon. Also, it is very important to know what is the interior and exterior of a closed curve. See, this is the closed curve, right? Inside this figure is called interior of the closed curve. Outside of this figure is called exterior of the closed curve, right? Curves that are polygons and not polygons. I'll give some examples for polygons. See, polygon means it's a closed curve, right? It's a closed curve and no intersection happening in between the lines, made up of only line segments, is called polygons. Even a rectangle, a triangle, a square, these are all polygons. So what are all not polygons? If it is like this, it is open, so it is not a polygon. Also, if it is like this, this is also not a polygon. This is open, so this is not a polygon. Polygon means a closed curve made up of only line segments. Also, there should not be any intersecting lines. That is called a polygon. Have a clear concept about polygons. Polygon means a closed curve made up of only line segments and there should not be any intersecting lines. That is called polygon. Now, diagonals. It is a line segment connecting two non-consecutive vertices of the polygon. See, consecutive means next. Here, it should be non-consecutive. That means it should not be next. If this is the vertices, this is the next vertices. This is also the next vertices of this thing. So, non-consecutive means for this, non-consecutive vertices is this one. For this vertices, non-consecutive thing is this one. Non-consecutive vertices for this vertices is this one. So just know the concept very well. Then it is very easy. So it is a line segment connecting two non-consecutive vertices of the polygon. This is the polygon, right? Made up of closed curve, made up of line segments. So now we are going to, this is a vertices. Non-consecutive for this vertices is this one, right? So if we connecting these two things, this is called the diagonal. Similarly, this is also the diagonal. So these two are diagonals for this polygon. Now come here. This is a pentagon. How many sides? 1, 2, 3, 4, 5. Non-consecutive. What is the non-consecutive vertices for this vertices? For this is next. Next means consecutive things are these and this. Non-consecutive are this and this. So from here it will go like this, right? This is one diagonal and this is another diagonal. In the same way, for this, the non-consecutive vertices, consecutives are this and this, non-consecutive are this, right? This and this. So it will go like this. Similarly, for this, non-consecutive vertices are These are all consecutive. Next vertices. Non-consecutive means it will come here. This is non-consecutive. These two are non-consecutive. These two are non-consecutive. So we can have diagonal like this. See here. This is one diagonal and this is another diagonal. This is a square. You know very well how to do diagonal for this. See, two non-consecutive. These two are non-consecutive, not next, right? So diagonal will go this way and this way, one diagonal from here to here. Vertices means points. Keep it in mind. The points are called vertices. Next means consecutive points. For this vertices, these two are consecutive. Next vertices. Non-consecutive vertices is this one for this. So here goes one diagonal. For this vertices, this is non-consecutive. So here comes one diagonal. Now, see, this is also a closed curve with 4 sides. 1, 2, 3, 4. Right? 1, 2, 3, 4 vertices. So how the diagonals will be? Non-consecutive vertices. For this is the non-consecutive thing. So it will come here. One diagonal came here. For this, the non-consecutive thing is here only. So another diagonal will come this way. So there are 2 diagonals for this figure. Here, how many sides? 1, 2, 3, 4, 5, 6 sides. Also 6 vertices. For this is a closed curve with 6 sides. 1, 2, 3, 4, 5, 6 sides. How to draw diagonals for this? Non-consecutive. Look for the non-consecutive vertices. It's very easy. See, first exterior. Here, this is non-consecutive. So, one diagonal. And this is another diagonal. These two are non-consecutive vertices. So, here comes one diagonal. And these two are non-consecutive. Here also, we can make one diagonal from here to here. So, we can form diagonal like this. Now, this and this are non-consecutive. So, from here to here, we can make one diagonal. From here to here also, we can make another diagonal. We can draw 2 more diagonals out of this. See, these two are non-consecutive. So, we can draw here also similarly from here to here. So, like this also we can draw. These are the ways to draw diagonals for the polygon. Note, a triangle has no diagonal. Can you tell why? Yes, all vertices are consecutive vertices. See, for this, if this is one vertices means 1, 2, 3, right? Vertices. See, all are next. For this is the next vertices. This is also the next vertices. For this, these two are next vertices. No non-consecutive vertices available here for any of these vertices. So, there is no diagonal possible for a triangle. Keep it in mind. It's a sure 1 more question. Number of diagonals in a polygon having n sides is equal to, this is the formula, n into n minus 3 divided by 2. Let us check with our thing. So, what they are telling? Number of diagonals, D is equal to n into n minus 3 divided by 2, right? We will check for our diagonals. Just we have done, right? So, for this, how many diagonals possible? For this, how many diagonals? Number of sides. N is the number of sides. This is the formula. N into n minus 3 divided by 2. So, for this, 4 sides, right? 4 minus 3 divided by 2 equal to 4 into 1 by 2, which is equal to 2. How many diagonals here formed? Only 2 diagonals. So, this is right. Here also, how many sides? 1, 2, 3, 4, 5 sides. So, how many diagonals possible for this polygon? 5 into 5 minus 3 divided by 2, which is equal to 5 into 2 by 2, equal to 5 diagonals possible. Let us check how many diagonals came here. 1, right? 1, 2, 3, 4, 5. 5 diagonals came here. This is also a square having 4 sides. Having 4 sides means how many diagonals possible? 4 sides means only 2 diagonals possible. Here one and here one. This is also 4 sides, 4-sided figure. 1, 2, 3, 4. This is one diagonal and this is another diagonal. So 2 diagonals possible. This is a polygon made up of 6 sides. 1, 2, 3, 4, 5, 6. So 6 means, what is the formula? D is equal to 6 into 6 minus 3 divided by 2, which is equal to 6 into 3 by 2. If we cancel, 3 3s are 9. So 9 diagonals should come. Let us check. 1. This is one diagonal. 1. This is another 2. And this is 3. This is 4. Correct? 4. Fourth diagonal. And this is fifth diagonal. Center one is fifth. This is sixth, seventh, 8th and 9th. So totally 9 diagonals came. We are going to learn types of polygons. First one is concave polygon and second one is convex polygon. What is concave polygon? Polygon that has at least one interior angle greater than 180 degree. The shape is irregular and a diagonal lies outside a polygon. Okay? And at least a diagonal, not all the diagonal, and at least a diagonal. We need to mention here, at least a diagonal lies outside a polygon. Let's see. See, this is a concave polygon. See here. This is the angle which is greater than 180 degree. See all the other angles A, B, C and D. A, B and D are less than 180 degree. Correct? But this C is greater than 180 degree. See, 180 degree means always a straight line. This is called 180 degree. If a line bends in this way, means the angle formed here must be greater than 180 degree. This angle. This angle V type means always this is less than 180 degree. This way. Okay. If it is this way, here it must be greater than 180 degree. But this is less than 180 degree. Anyways, one of the interior angle is greater than 180 degree. So this is a concave polygon. Also see the diagonal here. How to do diagonal? Here one diagonal will come. Here outside, that means exterior part. A diagonal lies outside a polygon for the concave polygon. Now this one, here also this is 90 degree and this is 90 degree. These are all less than 180 degree. Correct? All these angles are less than 180 degree. But this angle is greater than 180 degree. Correct? Greater than 180 degree. Therefore, this is a concave polygon. Also, one diagonal lies outside the polygon. All the other are inside, interior. But exteriorly, we will have one diagonal for this polygon. So, this is a concave polygon. Next, see this figure here also. These are all less than 180 degree angles. These angles are. But see this is greater than 180 degree. So, this is a concave polygon. Also, a diagonal lies outside the figure. Inside also we have diagonals, but a figure, if it has at least means one or more than one diagonals outside the figure means then it is surely called a concave polygon. Next, convex polygon. Polygon that has all interior angles that measures less than 180 degree. Also, diagonal connecting lines be contained within the shape, that means interior, and have no vertices that point inwards. See, here this vertices points inwards, right? Here also inwards. So here in convex polygon, no vertices that point inward. All are showing outwards only. Just look at the angles. These are all less than 180 degree, correct? Also, the diagonals lies completely inside the figure. Here also, these are all 90 degrees in this rectangle. So, less than 180 degree. Diagonals are inside here one, here one. This is also less than 180 degree. Correct? These are all less than 180 degree angles. Also, diagonals lies completely interior of the polygon. So, these are all classic examples of convex polygon. See this figure. Here also, all the angles formed are less than 180 degree. These two are 90 degrees. Correct? 90 degree, 90 degree. Also, the diagonal lies inside here, like this. Only inside, no outside diagonals. So, these are all called convex polygon. Polygons may also be classified into two types, regular polygon and irregular polygon. What is regular polygon? Both equiangular and equilateral. That means it should be of both angles of equal measures and sides of equal length. That is called equiangular and equilateral. Equiangular means equal angles inside the polygon, and equilateral means all sides are of equal length. That's all. So this is called a regular polygon. See, it is an equilateral triangle. All the angles formed here are 60 degree each. Similarly, all the sides are of same length. So, this is a regular polygon. It is a square. Square means obviously all the sides are equal or of equal length. And also all the angles formed are 90 degree each. So, this is a regular square. Regular polygon square. And this is a regular pentagon, 5 sides of equal length and angles formed inside this pentagon are equal. Then it is a regular polygon pentagon. So regular means equiangular and equilateral. What is irregular polygon? Irregular polygon means at least not equiangular and equilateral. At least means at least one angle must be different or one side must be different. See here, this is a right angled triangle, right? So this is the hypotenuse. This side must be greater than the other two sides. So this is an irregular polygon. Here 90 degree will come. Here the angles are different. So this side, all the three sides are different. This is a rectangle. Here also all the angles formed are equal. But these sides, see the side, these two sides are equal. But these two sides are not equal with these two sides. These two sides are equal and these opposite sides are equal. Not all the sides are equal. Here another example, pentagon but with different length of sides. These two are equal, these two are equal and this is different. Then it is also the angles formed here are different. Here 90 degree formed, right? Here all the angles are different. So this is called an irregular polygon. Irregular means at least not equiangular and equilateral. So with this, our part 1 video for understanding quadrilaterals introduction video for class 8 got over. If you like the video, do subscribe our channel. I'll meet you in my next video, understanding quadrilaterals part 2 introduction video for class 8. Thank you.